In the original design of the robot, I only thought I needed to move the leg so that it would swing on the coxa, which is on this pivot point. It only needed to swing 120 degrees. So basically 60 degrees this direction, 60 degrees this direction, if we consider this my 90 degree point. But once I got actually into looking at how to code for walking, that was going to be a problem. So what I had to do is actually make a design change so that it could do 180 degrees. But this support bar was in the way, so I had to cut out at the top and down out here at the bottom. There we go. To get that so that it could actually swing all the way around. And then I found that this bar right here would pinch these, and so it couldn't swing all the way, so it required a cutout on both sides over here to allow the wires basically to come on in. So that's a couple of the issues that I ran into that I had to take care of. And then, and the other thing was that originally this bottom piece looked like this. It had the angle right here, but this angle was still interfering with this, so I had to cut this away some on both sides. So that's why that looks a little bit different. It's not as pretty. I used just some plain black paint instead of anodizing. I didn't want to break out all the anodizing equipment just for this. I may do it in the future, but for now it's going to have to do with some black paint. Here's a little video progress on the Hexapod robot. As you see, it's up and running right now. The green lights that are showing up around indicate that the foot sensor, which is located right here on the end of the foot, is actually touching the floor. The red light here is actually an error coming in from the P1 sensor board on network in leg 6. So right here, what it's doing is it's sensing a problem that it's transmitting back. Come around here, we can also see leg 4 showing a blue light, which is the leg sensor is not touching the ground, although if you look down here, it appears it is. But if I put a little pressure on here, we'll see very little pressure. It must have just triggered it enough to stop the leg. And it's also got a problem here that's being indicated. To actually know what the problem's errors are, we have to look at the debug, which is Chip. Thank you very much. This helps so much. We can look at, right now it says initially it transmits a string that tells the system the legs to reset. This tells it basically leg 1 through, you can see 1 through 6, to move to 90 degrees on the femur, 0 degrees on the tibia, and 90 degrees on the coaxa. The 1 indicates whether or not the leg sensor should be active or not. It's set, for this case it didn't matter whether it was 1 or 0, but then we can come down here and we start looking at, once it starts up, it moves to these positions, and then we can actually see starting position. It says, okay, let's calculate what this is in a XYZ coordinate system. So it says this value here comes in at these values. Now, in actuality, this is the actual value that's coming out of the P1 processor. It's saying we're actually at 894 instead of 900, and tibia angle of 0.9 degrees, because this is all integer set up, and the coxa is at 90, and it does that for each one of these. At that point, the program is going and saying, okay, I wanted it to move down, the leg tip to move down 75 millimeters. So it comes through and it says, okay, if you're starting at this angles, we're going to have to do that. You have to go to this position. And you can see this, the Z height, 709 versus the 634. And this is what that translates then to these angles that's transmitted out to the robot, to the individual P1 controllers. And we come down here and we can see, let's see, tibia. Okay, right here on the leg 6, there's a note, that red light that was coming on for that. That's because it had a no movement error. So the tibia was not moving where it should have, when it should have. So it was supposed to move to 2.4 degrees, and we can see it started out at, let's see, we go back up here. It started out at 8 degrees. So you can see it didn't move. And then at the end, we calculate and look at each of the angles and see what changed. And to start up, we're going to run a test. First off, we're going to move the robot up, the legs up, and then we move them back down again. That was 75 millimeters, and the concept was here to tell it to move each one 75 millimeters. But the thing is, the distance between it and the floor was actually about 60 millimeters. So each of them stopped just as soon as it hit that leg sensor. And again, leg 4 is showing it's not quite there. So I've got a little bit of work to do to figure out why in the world that's. It looks like the leg down sensor is triggering, but it stops and it's not enough pressure yet to keep it triggered. So I want to look at that too. And it looks like it's also got another, probably tibia not moving is the problem here. This time we're going to test it with the leg sensor being told to be off. So it's going to go down until it hits 75. So we can see it tilted a bit here. Figure out why in the world. Okay. This leg did not go all the way down. This leg didn't go down. And you can see on leg 5, apparently got a really weird signal to move to. You see all the legs should have been at about the same angle. So this is why I take it very slow on this testing. This is where the debugging screens come in real handy. We can look at leg number 5, which should be right here. It started out, and you can see the numbers here for the X value, Y value, and Z values are pretty close, except we can see the Z value is quite a bit off as compared to the other ones. So there may be the issue right there. And so if that happened, we go back down to here to 5 again. This calculates out when it told to move, and you see everybody else is going to right around 89 degrees. This one went to 104 degrees, so significantly more distance. And right there, and it told it to go the angle it wanted to go to get to the point that it thinks it needs to be is 138.9 degrees, with the tibia at 5.6 degrees and the coccyx still at 90 degrees. So this all feeds back to that original item right here, which says go a little further. So why it started out with that when we know it wasn't right, that's something I'll need to investigate. So this is where I'm at doing this stuff to figure it all out. The debugging is great. It's easy to troubleshoot and figure out what's going on. Sometimes it leads me down another rabbit hole, but it does end up making things better because I can fix things before they get any worse or further down the line.